Hello, everybody. Welcome to Architecture Talk Tongue. I have a guest, Zvonko Vugreshek, who actually is teaching at university and doing projects with AI and parametric and computational design. And it's really interesting how he formulated his mission statement, sculpting dreams through code and digital design, which I decided to borrow and name this conversation as such. Zvonko, thank you so much for joining me today and agreeing to be interviewed.
Yeah, thank you so much for inviting.
It's a
Um,
pleasure having you. I really love actually finding out more about the work of code and AI and computerization. I'm not in that topic so much, but I really love to follow right now like how technology is advancing. And I think that just like parametrics did, AI right now will be disrupting how we design and perceive design as well. So I wanted to kind of pick your brains a little bit about this. But why don't you just start with kind of introducing yourself and telling us where you're at right now? I know that you're connecting from Berlin and you work there for a company that specifically works with code for design. So tell us a little bit about yourself, and then we can move to talk a little bit about the technology and AI and computerization.
yeah. Okay, so officially, I'm Zvonko Vugreshek, and I'm uh, currently a computational designer and a developer and a digital fabricator and uh, all of these kind of things. I'm currently working at the innovation lab called N Frontier here in Berlin, and we are doing this kind of explorations and uh, into this kind of emerging technologies. So we're actually a tech company, we're not an agency. We're producing stuff massively, or doing uh, uh, a car, literally we made an EV vehicle that's should hit the streets uh, soon. You can check it out on design. It was on Design Boom. I can share you the link, and we're doing all these things currently now with AI, with ML, with uh, generation from text inputs, from prompts, from uh, images. You can also use as a starting base, and all of these kind of new technologies and emerging tech, we're kind of bridging them to the physical world, not just letting them stay somewhere virtually on some computer, some image, some Photoshop or whatever, but actually uh, making them being usable in physical space. and and before that, I was teaching at university. I was teaching at the what's it called, department uh, for computational design. Okay, it was the official name was bio-inspired architecture and sensorics at the technical
Nice.
university in Berlin. And before that, I was also in a similar position and in the uh, technical university. Okay, the University of Technology in Cottbus, that's near Berlin, a city near Berlin, and there I was working with robots, uh, automation of the industrial processes for the construction industry, 3D printing. Okay, not too much 3D printing, but concrete spraying and all of these processes that can be automated with digital fabrication or with robots. And before that, I was uh, living in Denmark. I was working for 3XN for a short time, doing optimization projects, getting. I was working on mostly also kind of machine learning tasks and regarding optimization, regarding how the things get built actually, like actually doing this digital fabrication workflow of projects that needed to be built or complex shapes that needed to be optimized to be built for this kind of easing this logistics, let's call it, or this kind of way. How do you actually build what you want to build? What looks like a cool shape on your screen, let's say.
I love this. So actually, that leads me to a question I wanted to ask you. How do you actually make a meaning out of crazy digitally modified or generated shapes in architecture or for design altogether?
I mean, that's a broad answer that uh, points to an even broader like question. That's why you need to you need to define what do you actually need. I mean, what is it gonna uh, what is gonna mean? Like, what's the point? Let's call it like. I mean, if it's like a if it's like a tower, if it's like a roof, if it's some kind of a wavy roof, that's some crazy uh, twisted
Design.
twisted kangaroo forced relaxed uh, shape that uh, you need to planarize them. You need to make them flat, or you're gonna like deal with curved surfaces, which are gonna be expensive. Or, I mean, that's all cool. I mean, if you have the money, why not? If you have the budget, if you have the resources, oh, why not? But like, in order to stay uh, within a budget or within tight resources, you need to like optimize. You need to like uh, get everything flat for example, or like cluster stuff. Like if you see this behind me, this could be like a some kind of a roof or some kind of a facade, and all of these behind, like they're panels. Okay, they're relatively relatively a quad shape. So like so you can find the clusters within all of these, uh, find the common shapes or find the common tree shapes or X shapes, something that's like not leading to each unique part. I mean, unless you have the money. If you rationalize them to like three shapes or five shapes or X shapes, like then it's gonna be much easier than for production for this general logistics part, because when you send to the machines, you can just send uh, 5 sets of parts 3,000 times, and the machine will just cut because the machine is blind. The machine doesn't care. The machine just cuts, and it can go into like just a production line, and there will be minimal errors. And like then when it comes actually on site, like the builders are not gonna have to be playing a huge Ravensburger puzzle out of 6,000 different pieces.
Yeah. That makes sense. I think that it's been like a long debate about the meaning behind using those tools. And I think, you pointing as to what's the purpose behind it is great. But let's admit we're designers and sometimes we come up with cool shapes using and playing with this technology. And how do you make it feasible, practical, and introduce, let's just say, how do you convince your boss that your shape or your design is buildable and also financially feasible.
Yeah, that's the point where you have to introduce higher programming powers, let's call them, or like it's not or just introduce machine learning, or I'm not talking about AI here because like if it's an existing thing, if this behind me is part of a twisted tower that's like even more twisted, that's going up, and like you already have the design, you already have the panels, you already know how it's gonna look initially, but you need to like actually rationalize it and like optimize it that it's actually feasible, that it fits within specific panel requirements, that it fits within uh, glass. Imagine like you have these kind of, I don't know, profiles from Schuko, like whatever was this Sanko glass, or whatever manufacturer you're gonna end up with. Actually, they have standards, they have like panel requirements, they have glass requirements, they have a ton of parameters that you must obey for your crazy shape to become real. And you need to use, I mean, you can do that manually. It will take you a bit of time, like, or you can just like run on prediction, run on optimization, run some kind of a algorithmic help. Let's call it, to solve that for you. I mean, of course, the shape might be distorted. The maybe the panels won't be so unique or so curvy or so distorted or however from the original thing, but it will be feasible. It will be planar, it will be more or less the same, it will be like clustered into X sets. So so that at the end of the day you would have like a thing, you would have a list, you would have a report of the, maybe you can also add the costs to the calculation and like all of these numbers that the financial department likes, and 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 then you can like actually confront your boss or confront your client or whoever is your your
Yeah.
superintendent. Like,
That's amazing. I love it. Thank you so much for this answer. Elena asked if she can ask a question. Yes, you can. Elena, please drop it here. I wasn't able to respond from our streaming software directly to LinkedIn, but you can drop your question in LinkedIn in the comments and we will attend to it. In the meantime, I will ask my other question. So you spoke a little bit about AI, and I wanted to dig deeper into it. Tell us a little bit more about switching from digital fabrication to AI, and what is that process like? Where are we? What are we looking at? And also, what can be the challenges from that? Because we are relying heavily on computer intelligence and computerization, but I think that the sort of human touch is necessary to lead it towards a good meaning. But I wanted to kind of get your opinion on this, and also I'm sure you're more in the AI. Maybe you can tell us about some interesting technologies that you are working with.
yeah, I mean, currently at End Frontier, we're developing a lot of tools for with AI, like from like 3D model from image, or like like utilizing the latest technologies, like from text to 3D, and like from point cloud to 3D, from all of these things. That's like currently under development and testing. Like I'm doing that personally, and you might see some results on our Instagram and on LinkedIn of our trials, and and Actually, it's like to get back to the general question, like it's like a very tight link because like uh, the base principle is the same. Like when you're into the general like computational thought, like in general this kind of computational design thinking, like uh, it's irrelevant. Like I mean, when I was teaching to students like at the university, I always I didn't really bother to teach them too much uh, how to I mean uh, grasshopper or whatever like in itself, like in this sense that like okay, now you click here, you click there, you have a line component, you have a I don't know, a loft or whatever, because like that comes kind of naturally when you understand the general logic of how things are built. And in this case, the general logic is that like computational design and machine learning and like is kind of the not the natural progression, but like it adds up. Like if you have already started with computational design and this kind of thinking and went into writing proper code like uh, Python and C# and all of these kind of things, and uh, learning machine learning is just a matter of like just adding some statistics and probability and like uh, uh, this kind of more mathematical stuff. And then if you want to go even deeper like into deep learning and neural networks and stuff like that, that's just an additional layer. And the third layer is like reinforcement, like when you teach like an AI like a baby, like literally you have to like baby walk the AI then, but then the AI can develop his own consciousness and like uh, his own like not thoughts, but like it's gonna be able to like figure his way out.
Mm-hmm.
On on one webinar I did with Design Morphine like a couple of years ago, I did this whole webinar machine streams, and at the end there, we did this kind of reinforcement learning algorithm that's uh, uh, makes you can teach Rhino or like Grasshopper how to drive a car within an imaginary circuit in Rhino. Like,
I love
and
this. Teaching an algorithm to drive a car in Rhino. That's incredible. Elena dropped her question. It's a bit long, but I will read it
mm,
through here. So she says she's got an AI question. In realm of architecture, as in any creative industry, we have trendsetters that are inspiring a certain aesthetic, be it Zaha Hadid, Sana Libeskind, or Richard Mayer. The designers often cannot reach the same quality of project, but still would like to follow the trend. Working with AI, do you see a possibility of artificial intelligence generating designs in a certain trend, given that we can feed it the building program and known restrictions?
now this is kind of an current topic, especially uh, with the AI image generators like I don't know, Stable Diffusion, uh, Midjourney, DALI, and all of these, because they're actually feeding in on images from creators in general, like from Zaha Hadid or I don't know, Norman Foster or whoever, Van Gogh, or I don't know, why not? If you want to make a I don't know, a cheese grater in the style of Zaha Hadid, yeah, you can. It will generate an image uh, uh, like that, and like and now there is like mm, maybe it's a moral question or an ethical question that like is that is that leading to like more of a unified style, or like is the actual style, like in general, like so being like abandoned, because you can create styles like images or now even 3D models and stuff like that in the style of whatever, like probably, or at least influenced by something. So like I don't know that's I don't know that whether that's good or bad, because then what's a unique style, right? Because like what's then your unique style? Because before that, like uh, when I don't know, Corbusier was doing his thing, or like Zaha Hadid was doing his thing, like not many people could copy that because they couldn't really do it. Like in general, there was not really uh, how to copy it. I mean, obviously, yeah, you can, but like they were the first, and I don't know. That's like a very broad discussion. Like, how do you start a style
Mhm.
or a trend?
Definitely. I mean, I think that certainly if it comes to copying, there's like a lot to say to morality. But I think that with certain designers, if there is a style already within the office and you now want to go into AI and start experimenting with like, those tools available to you to generate more of the designs within your own style, that could be actually very useful. And, for example, maybe with bigger offices we only can talk to like Zaha or the kind of offices that have a very specific and distinct design style. There is a lot of offices that you can see that they're pushing very strongly on sustainability technology, and therefore their designs, if you just look at the building, you can't say, okay, this is definitely this architect, right? I think maybe SOM is a little bit like this, that they can just create like more technologically advanced tall buildings or something, but it could also be done by a different designer. Sorry, SOM. But yeah, basically within like this segment of, let's just say, design, where we do have a style, we have a certain aesthetic that we're adapting, it would be really interesting to explore how those tools can actually help that, with maybe a generation of spaces, or even like sculpture, furniture that can go in, and other things. So, do you think that there's this kind of way in which we can teach the algorithm a style and keep experimenting within an own office, not trying to copy another designer, but like try to generate more of a design that is of our office style?
I mean, yeah, I mean, in general, yeah, theoretically, like I mean, whenever you're trying to like teach something a computer, like not even an AI, like just generally like teaching a computer anything, like even ML for predictions for whatever, you need to understand you're talking to a blind person, like literally, you're talking like to a uh, blind, deaf, whatever, blank person. So you have to literally spoon feed it like with everything. Right? So,
Yeah, yeah, exactly. So that intelligence is still, like you said, blank. Basically,
yeah.
there's a lot of gaps to fill, and yeah, right now, it's at a very infant state. I love that clarification. So we've been using computational like tools to sort of generate and predict things for us in architecture. Like, for example, tools that can show us whether the site is correct for building, let's just say how the sun will behave throughout the year, weather conditions, whatever, those type of things. We know it, we're familiar with it. How can AI now step into this predictability and help us streamline a process better?
I mean, I would say that's more of an ML thing, that like I would use AI personally, or like what we need to like define like a line, what is AI and what is ML, like as like all the hardcore computation, like all of these predictions and analysis and getting an optimized solution, getting a number, literally, because at the end of the day, you only get a number. Like that's a machine learning thing or a statistical thing, and that has been here for quite a long time. Like there hasn't been any probably major improvements like for a long time. But architects or the AAC industry and designers haven't been using it too much or haven't been like uh, really into that domain or how they can like actually put it into advantage. But like so like but all of these generations and like um, how do you get the optimal, I don't know, roof shading like or facade shading? How much percent of your of this guy behind me like should be shaded? How much should be like actually opaque or like transparent or like depend, or maybe it's like a facade that's like reactive, like kinetic, that's like if this is actually sits anywhere in the world, like according to that geoposition, we know uh, how much sun, there would be sun hours, how the sun rays hit, how we can get the vector of the sun rays, and like for, I don't know, the key times of the day, or in this, at the end of this whole data stream, that's the end of this like if and else and if and else and if and else uh, stream, like we can get like an, a number or like a series of numbers, like some like okay, optimally to cover most of the cases of uh, this guy behind me should be, I don't know, 60% transparent, 40% totally blacked out, or like I don't know what. I mean, all of these data can be used. So like, but now there's like a thing like how many firms would they or designers or whoever's gonna be in charge of actually executing this stuff, or who would stand behind this, would actually be willing to do that. I mean, because like doing this, like it's not just like uh, okay, now we're fancy, this facade is like uh, shaded like this because of all of these if and else and uh, streams, but doing so like inside the working conditions would be better, because like suddenly if this was like whole 100% glass like all the time, like non shaded, nothing, like, and it's 40 degrees outside, like inside would be like a greenhouse like, so
Absolutely.
like yeah.
So how
So that,
much can we trust AI to predict those type of things for us right now?
right now, I mean, it's I wouldn't. I mean, I would trust it uh, as a guide, for sure, as a guide, because the solutions it would give you, or ML, like the predictions that would give you, you would, as a human, you would never achieve in such short amount of time. I mean, talking from a human perspective, but like that is like 100% like true and should be blindly followed. Not really. I would say it's right in 90% of the cases, at least for the initial guesses. uh, for these hardcore data things, like this shaded and like penalization and like percentages and everything that has to do with raw data, where you have where the actual number at the end is the thing that counts. Like there's no better way than ML for it currently. But if it's more of a thing that's uh, more subjective, or more thing that's like not really easy to teach to an algorithm, then like it really sucks. I mean, uh, we have witnessed that with a lot of these kind of floor plan generators and like uh, fa- I don't know, facade generators or whatever, like that they make kind of uh, not socially nice solutions. Like, not, like, I mean, it works. I mean, theoretically, like in architectural standards, or like by Neufert standards or whatever, probably it would work. It makes sense, but like as a human, or like as a social being that has to like live and work and spend time there and do everything, like would you actually spend time there? I mean, some of the solutions are kind of bizarre. I mean, I have seen solutions that like go from the front door straight into the bedroom, and like, I mean, that's okay. Probably that's might be the most optimal way if because of, I don't know, the circulation and like, I don't know, the access to all the rooms, and um, to not be too far from the bedroom to the bedroom, or whatever parameter you might want to set. Like uh, if the, I mean, imagine a solution situation that like when somebody is coming from the front door, and like you're just like uh, coming from the bedroom, like opening door and clashing with them, like coming on. Uh,
Yeah, not too practical.
Not too practical.
We
Uh,
have actually another design AI question. I'm going to drop it here. Oops. Yeah. It says, "Hi guys, I see that AI is useful for analyzing and generating and sorting out research data in architecture industry. Maybe in the future, I'll also be able to do the architectural drawings. But how far do you think it is from doing the actual designing according to the requirements and needs of the clients?"
and that's a, I mean, as I said, like I have already seen algorithms and and workflows and stuff, things like this that actually do this kind of drawing and like suggesting floor plans and room layouts and all these kind of things, given that like say you want to say, okay, I want to have a bedroom flat with I don't know, two toilets with the bedroom connected to the living room or whatever, and a balcony and stuff like that. I mean, those things already exist. I mean, I have seen them, but like the thing is that, as I said before, like uh, putting them into actual motion as a human or as a planner, or like it's not really logical, or it's at least not in the human eye, like socially logical, like because they might be optimized, they might be the theoretically best solution, but still you can't and plus you can't be too picky with your wishes, for sure, like, and like so like if your client is one of those typical clients, the typical architectural clients, or especially private clients, which are like, okay, can we change this now? Like my wife doesn't like red. I don't know.
Yeah. No, that makes a lot of sense. So to wrap this up, one last question. And it's, whenever I talk to my mama, for example, about all those things, like recently I told her about ChatGPT, and she always says, will it be possible that like the AI will take over like human, roles, and I don't know, the different tasks that we complete in our daily jobs and whatever. So computers versus humans, do you think that we still will need humans to
Of
manage
course.
all of this AI, or is it just
No,
gonna push us away?
no. The humans will always be there because we still haven't gotten to the point that would have an AGI, which is like an artificial general intelligence. So far there will always be a need to have a human observer. I mean, I mean, uh, right now, I would say AI won't take your job, or like as a designer, AI won't take your job, but like uh, the designer using AI to help himself will take your job.
I like that. Yeah, good one. Awesome. Thank you so much. This was awesome. I really loved it. Thank you for everyone as well listening in and asking questions. So, if people wanted to connect with you, is LinkedIn the best option?
LinkedIn, Instagram, I don't know. Like, can I put links here, or like, how do you
Please.
do that? Huh?
You can drop it in, wait, you can actually add it as a comment right here to all in the chat, and it will just be posted to all the platforms that we're streaming to.
Uh, I can't I can do comments currently.
No, you can. Okay, so if
I
you
can
drop
just
it in the private chat between us, I'll drop it in the comment.
yeah. Okay.
So let's do that. And yeah, thank you so much, guys. I love the AI talks. It's been really quite an interesting ride right now with seeing all these different interesting tools popping around. A lot of architects are playing around with ChatGPT, and I think also AI right now for computational design. It's going to be quite a bliss to step into for sure. So it's great having these conversations and knowing what's out there. And I do encourage you to play around with those tools as well.
Yeah. No. It's a thing now, because like it's making us lazy, like, but in a positive sense. Like uh, the main thing that uh, made me do this is actually not to change stuff manually, or not to like uh, or reduce your general workloads, like this kind of like in architecture especially, there's like a lot of repetitive work and a lot of like back and forth and back and forth and manual back and forth.
That's right. I dropped the comment. It's also visible right here, guys. And this is the Instagram. So you can find and connect with Zvonko on Instagram and LinkedIn. Thank you so
Yeah,
much
and
again for
on
joining. Thank you for everyone tuning
on
in.
this
And we'll see you all soon.
I will also drop you, like, uh you can find me in, I don't know, Design Morphine. You can find me on my company currently. It's in Frontier. You can just like check them out as well. And like I was on uh, Design Boom where we launched this car. I told you it's called the Eula. Uh, um, Let me just find it.
So this is the company and Frontier in
Yeah,
Berlin. That's Zvonko works
yeah,
for, and their innovations. You can follow them on Insta.
yeah. You can follow the chairs and stuff, like uh, these AI things I have been talking about. Yeah, and we were watching. We launched this, and today we were riding it around Berlin. We had a visit from a big television company here in Germany, and
I like that. Let me just let's see if I can do this. I'm gonna. Oh, no, I did not this here. Can you guys see my screen now?
Yeah, I see your screen.
Excellent. So here's the car. It's great. I love it.
I see your Gmail. I don't.
Oh, really? It
Yeah.
did not. Oh, such a shame. Okay, never mind. That didn't work. Wait, let me stop sharing. Okay, that didn't work. Sorry for this. I was trying to share my. I was like looking at the beautiful design, but okay, never mind.
I can share my screen like and play it from there.
Okay, awesome.
Like where was it? Now you should see it, right?
Let's see. Oh yes, here. Perfect.
Yeah. Now you're seeing it. Come on, no. Yeah, this was literally in front of our studio.
I love it. What is it built out of?
It's ABS. It's like almost entirely 3D printed.
Excellent.
And it was on Formnext, like the fair Formnext in Frankfurt. It's the biggest 3D printing fair in this thing. So we were test riding in there. So it was in Frankfurt. Yeah.
That's wonderful. I love it. It's great. So next time I come to Berlin, there's gonna be cars like this around.
Oh yeah. For big cities, it's awesome.
Yeah, for sure. Easy to park because it actually takes like a motorcycle.
Yeah, I was talking to a friend in Copenhagen. She was like, this would be so awesome for there because like, you know how Copenhagen is with biking and stuff, and they're like, this is so awesome, like to be sheltered, like, and it's like kind of a bike because you can also run it on a bike lane. It's small enough.
I love it. That's great. Thank you so much for joining this podcast and showing us your work and answering all the questions. It was a pleasure. And thank you also to everyone listening. And we'll see you all soon. Bye.
No problem. Pleasure. So see you soon. Come if you're around in Berlin, we can have a beer.
Yes, sounds great. Take care. Bye.
Cool. See ya.